All right, in this question, we're going to find the local and absolute max and min values of f, and then we're going to sketch our work. So up until now, typically what you'd want to do here is you'd punch this into your calculator, and we'd be able to get a rough idea of where the max and mins are. But we're going to be doing this all by hand now, because we are in calculus. So what I'm going to do to begin with is I'm going to make a little sketch, just really rough, just to get a feel for what I'm doing here. So if you remember from 30-1, we have a degree 4 polynomial, and the leading coefficient is positive, so this thing would start high in quadrant 2, maybe do something like this, and then back up again. All right, and why that's kind of helpful to begin with is that I want to find my local and absolute max and min values. So I can see down here, I potentially have like, a local max here and an absolute one here, right? Maybe a local max right there. But I'm not going to have an absolute max because this thing goes on to infinity in the y direction, right? So it gives me a bit of a starting point. So now that I have that, let's find the derivative of this guy. So we're going to say, okay, f prime of x is equal to, and then this would be 12 x to the 3 minus 48 x squared, and then plus 36 x, and then that's it. All right, so now what we're going to do now is we're going to set this equal to 0 because this is what's going to tell me where my derivative is equal to 0. So like just as a reference here, I want to know where the slope of this guy is 0. That's really what we're doing. Because where the slope of this guy is 0, that's where it's going to either be a max or be a min. Okay, so I can't really see it yet, so we need to factor this. And you're probably thinking, oh no, this is one of those like cubic ones that are a lot of work to do. It's not so bad because there's actually an x in every term. So let's just factor out an x first. So let's factor out an x. Actually, let's factor out more than just the x. So we're going to factor out 12x. Okay, and then we have x squared minus 4x plus 3. And then we'll factor this quadratic. So we get 0 is equal to 12x, and then x minus 3, and x minus 1. Okay, so then from here we can see where our what our critical numbers are, right? Our critical numbers are going to happen when x is equal to 0, 3, and 1. All right, so now what we're going to do is we're going to create a number line with our critical values just to kind of figure out where our graph is going to be increasing and decreasing. So I'm just going to make a number line here. It doesn't have to be perfect. And just plot these points. So we're going to have, let's say, 0 right there. We're going to have 1. And then we're going to have like 3. All right, so these are the ones I'm interested in. And I know that really at this 0, 1, and 3, this is where the graph is going to turn around, right? I'm really thinking this is where I'm going to have a minimum or a maximum, right? And you can probably already tell what it's going to be based on the graph that I sketched, right? Kind of what it has to be. Like if this comes down and then goes back up again, that's probably happening at my 0. But let's do this for good measure to make sure. So now what we're going to do, let's just think of our original function, right? So our original function, let's think of the derivative of our function right here. So here, I'll write it one more time. So let's say the derivative of x was 12x, and I'm going to leave it in factored form. So x minus 3, and then x minus 1. Okay, now what we're going to do is we're going to test out this derivative of x in different sections. So let's test it out over here, right? Let's test it out on this side. Well, in that case, if I threw in, let's say, -1, right, or any negative number into this thing, then what we end up getting here is we'd have something like f prime of x is going to come out as, well, 12. The 12 doesn't really matter here, but 12 times a negative, and then times a negative. So they're all negative, right? So this thing is going to come out negative. All right, so what does that tell us? Well, if we have a negative derivative in this section, well I know that this is going to be a decreasing function in that section. which is really what I was expecting, right? It's a decreasing function in that section. It's coming down. All right, so that's what's happening from up until 0. Okay, so decreasing in that section. All right, and now from 0 to 1, well, in that case, we're going to have, well, it'll be 12, and then x is going to be positive. But if I had, let's say, 0.5 in here, right? 0.5 is like the number between those. Then this would be negative, and 0.5, this would still be negative, so this thing is going to be coming out positive. Well, that makes sense. I was expecting that too, right? So now our graph is going to be increasing. I just draw like a little arrow there just to kind of remind myself whether it's increasing or decreasing. And then between 1 and 2, or 1 and 3, so if I just chose the point 2, for instance, then that would be positive. This one's going to be still negative, and this one's going to be positive, so this is going to be coming out negative in this section. Okay, and then for 3, when I'm above 3, now they're all going to be positive, so it's going to cut, my answer will come out positive. And then we have this happening. So that made sense, right? I was kind of expecting that to be the case when I was looking at my original picture. All right, so now all of that was really just to make sure that this really was the case, that I had a minimum and a maximum and a minimum happening there, right? So now if I want to sketch this thing out, I know where my x values are, where these are going to happen. The next step would just be to figure out what the y values are for each of those as well. And then once I have that, I probably have a pretty good sketch of this graph. And I can probably go from there. So let's do that. So let's say, let's actually just write each of these down now. So we'll say, okay, where is f of 0? So f of 0. So if I threw 0 into the original function, so 0 into my original function, you can probably see from looking at that it's going to come out as 3, right? Just that constant term. All right, so then if I have f of 3, doing this a little out of order, but that's fine. So if I had f of 3, that's going to come out as negative 24. I didn't write it down. I'm figuring you guys can probably do that from here, right? I'm just really throwing in 3 in place of x for this and seeing what comes out from my original function. And then f of 1 is going to be 8. All right, so then we have enough info. We can probably sketch this thing now. But I guess, you know what? Before we do that, let's even just say what we think these are, whether it's an absolute max, minimum, local, max, or minimum. So f of 0, so it's at 3, right? So I can see right now there's a lower point. Okay, this must be a low point though, so this 3 must actually be a local, I'm going to try a little arrow there, a local minimum. Okay. Yeah, and I can tell it's a minimum, right? Because it was on its way down, and then it's on its way up, right? So that's my local minimum. At, let's say, f of 3, well, again, that's a minimum, right? And is it a local or is it an absolute? Well, it's definitely lower than this 3, right? And it never gets any lower, right? That's the lowest it gets. And I know the graph goes up to infinity on either end. So this is actually an absolute. I'll say ABS minimum. So absolute. Okay. And then f of 1 is equal to 8. So you can see at 1, right? That was on its way up and then back down again. So this is a maximum. But is it an absolute maximum? Well, no, because the graph goes up to infinity. So this is just going to be a local. So a local max. All right, so let's do a better sketch of this guy now. All right, so now to sketch this one, let's first just plot our points. So f of 0, and I actually knew where this point was to begin with too, right? Because I was going to draw this either way. This is actually the y-intercept, isn't it? But it's also a critical number. So let's just write 3. So I'll just draw a point there, and then we'll write that 0, comma 3. Oop. Good enough. That's a bracket. Okay. And then the next one, so the next one over would be at 1, 8. So at the point 1, I'm going to be up at, somewhere up here at 8. So say something like that. Maybe I'll write above there too. So this is the point 1 comma 8. And then we're going to have way down here, and this isn't really going to be to scale because I want to have it like on the same graph here, but at 3, so when x is 3, so maybe we'll say like over here somewhere, it's going to be negative 24. So 3 comma negative 24. So I would want to see that you had these points all on your graph, right? And then this was a local minimum, this first one, right? So this came down. So now it came down. This was my minimum point. Goes back up again. This is my maximum. Comes down here. Sorry, I got a very unsteady hand right now. Let's pretend that's a straight line. And then through our last point. And then I know it turns, and it's a minimum, so it must go on to infinity all the way up. That was terrible. Just make sure you guys do better than that. Just having it's just a bad pen day. All right, you know what I mean though, right? Try to do it better than that. Like, this is just my pen's not doing well. I wouldn't be so happy if it was like that if you were doing it on paper. But okay, so there you go. So that's our graph.